everyone. Okay, so the topic today is for logarithmic functions using substitution. Some questions, okay, you do not really need to use the substitution, but some of the questions they should use the substitution. Okay, so we cannot get out of here. Okay, so we have to learn about how to use the substitution method properly for the integration questions. Okay, let's go. First one. Okay, so what's your headache for this? It's a headache. It's so annoying. That is one of the good candidates for making your substitution. Okay, let's do it. Okay, so let's try to make, let this be something like this one. Okay, let's substitute this one to u, and then we're going to cube for both sides. Okay, we're going to cubic for both sides, and we'll see this one. Okay, and then this one, you have two choices. Your first choice is differentiate x in terms of u. It will be 3u squared, and then you can multiply du to this side, so dx equals to du. Does it make sense? The other way is over here. Okay, the other alternative, if you get used to do this sort of way, so x equals to u cubed. Okay, I'm gonna differentiate this by x. Okay, so I'm gonna differentiate this by x. I'm gonna differentiate this by u. Okay, you need to tell them separate, specifically. So you're gonna differentiate this by x. What is it? It's 1. Then you need to tell, I differentiated this left-hand side by x. Just write it. And now I'm going to differentiate the second part. Okay, so u cubed in terms of u. So differentiate it. So it will be 3u squared. And you need to tell, hey, I differentiated this right-hand side by u. So you need to tell u. This is more direct. This is a little more indirect. But either way is fine. Okay, as long as you feel comfortable, please use that way. Okay, so this is how we make it. Okay, whenever you have you made a substitution, guys, you always differentiate. Okay, because we're trying to replace every x by the letter u. Okay, and then dx, yes, dx should get replaced by du. That's why you have to differentiate. Okay, let's moving. What I did here, so first of all, dx, so dx is 3u squared du, replaced, right? Dx is replaced over here, so 1 is 1, it's not changing. And then cube root x equals to u. I just write like this one. Understand that? Okay, so it's a good start. What I like to do, guys, yes, if you have any coefficient, please take it away. Okay, take it outside of the integral, like this one. Anyway, what happens from here? Okay, so it's a good candidate of being the kind of differentiate and not differentiate, okay, format. But this power is higher than the numerator. Do you remember that the previous lesson? We tried to diminish this power to less than 1 over this one. Okay, so what I'd like to do, I want to make -1 plus 1. Why? Well, -1 plus 1, say u plus 1, u minus 1. So we can cancel these two later. So that's the idea. Okay, so separate them. Okay, I separate these two fractions, factorize them like this. Factorize. Okay, this is what you have to forecast. Cancel them. So what's left over here? Okay, now this is too easy to integrate. This one can be rewritten 1 plus u dash. Can you see? So differentiate divided by, not differentiate. Okay, will be ln. So I'm going to write it. So u can be, u is integrated u squared divided by 2. 1 is integrated by u, and 3 ln 1 plus u plus c. Not finished. What do you want to do later? Okay, what do you want to do after this one? Yes. So just make sure you need to write your answer make the question satisfied. The question was written in terms of letter X, but the answer is written in terms of U. There's no indication this is the answer for this one. Okay? The U is introduced by yourself and ourselves, so Marcus does not know what U is. So, okay, so you have to put it back. Okay, you have to put it back. So U, what was U? U was here. So that was U. So take it back over here. So U square is changing like this. U is this. Okay, so that was U. This is what we leave, and then U is there. So that must be the final answer. Okay, just be careful all the time. Most of people leave the answer like this, just U. No, you will lose your mark. Make sure you gotta write the answer, whatever letter is being used in the question. Okay, so that's the important part. So that's the first question of the substitution. Okay, we're gonna move on. Question 6. Okay, very kindly, this question 6 gives us what to substitute. Okay, what to replace. Okay, what do you want to do? You have the substitution here. Okay, then we're going to differentiate here. Okay, like this one. So we're going to differentiate here. Okay, differentiate U in terms of X. So differentiate the ln X will be 1 over X. Okay, I want to write the cross multiply here. So X times du is 1 times dx. It's like this one. Why do this? Is here, this dx will get replaced by x du later on. Make sense? Okay, we're going to write this one just in terms of u. See what happens? Like this. So 1 is 1, x is x, log x is u as we substitute, and then dx is x du, so x du. So dx is replaced by x du. Okay? It's all planned. Okay, any idea from this point, everyone? Cancel it. Cancel, cancel. Make the question nice and easy. Always cancel. Always, whenever you see the questions, if you find anything, cancel, cancel, cancel. Okay? Don't leave anything uncancelled form. Now, if you cancel x and x, what do you see? 1 over x. Yes, that is u dash. So differentiate divided by not differentiate is ln x. Sorry, ln u. Okay? And any reminder? Yes, do not leave your answer u. So a question is written in terms of x. So you have to write the answer in terms of x. Okay? So how to write it? Use this one, put this back into here. Okay? So which is this one. That's the final answer. Understand that? Okay? So just one thing, I'm repeating what you have to do. Most of people leave the answer like this one. So I don't want you to do this. Okay? Once you think, okay, I'm pretty sure this is the right answer, always go back to the question, what was the, what the letter was being used in the question, and take into your consideration, write your answer with the same letter as in the question. Okay? That's question 6. Question 7. Okay, what do you want to do? What do you want to do? Okay, in this case, okay, so we do not know. So we must make a decision to choose the right part to be substituted by u. Well, I think ln x is a headache, so let's make ln x equals to u. Okay, always good attempt. And then differentiate both sides over here. Okay, I'm going to differentiate u in terms of u. Okay, so it's du, so 1 du basically. And ln x is differentiated in terms of letter x, so ln x will be 1 over x. You know, tell is I used letter x in differentiating. Does it make sense? So it's so close, okay? So what you are seeing here, the dx here is that one, same thing. So we're going to replace everything by du. And ln x is replaced by u. So simple. Can you see this? So ln x divided by x is separated by ln x times 1 over x, okay? That is same as that one. So what do you want to do over here? Okay, ln x is u, 1 over x times dx is du, okay? so simple integration, okay, which is half u squared plus c. Put u back into here, there will be the final answer. Same story, okay, nothing surprised, okay, nothing surprised. But for this question 7, is telling you about, okay, what sort of letter, okay, what sort of part of the question to be substituted, okay. What I was saying to you, okay, take a consideration your first time, or your headache, okay, that's always the good candidate to substitute or replace it by any other letter rather than x, okay. So that was question 7. Let's move on to question 8. Question 8, okay? What is your headache? Well, I'm thinking that may be the headache, okay? That's so annoying. So put it in, okay? Let's make it just u, okay? Any other letter. Differentiate as usual, okay? I differentiate u in terms of x, which becomes 2x. You can make something else, okay? I just swap them. So that dx is replaced by du divided by 2x. That will get replaced by this one, okay? We are actually ready. Yeah, put it in. X minus 2, I don't know, just leave it x minus 2, okay? X minus 2, okay, if your first step is this one minus 2. How do you know? It's so difficult, okay, for the beginner. But if you get used to do a kind of 4-unit integration, you can think, okay, this is 1 power more than the numerator. Okay, it's a good candidate of ln something. Okay, I don't know. Or you can use the substitution for this one. Okay, but this one is simply is a part of the integration of the log. Okay, the second and third formula. Do you see that? So x squared plus a squared. Okay, you can just simply follow the formula. Okay, so that is the idea why we separate them. Okay, we move on. Your first step, so x is x, and then x squared plus 4. X squared plus 4 is replaced by u, so I just write u. And then dx, this dx will get replaced by du divided by 2x over here. Can you see? On the right hand side, 2 is coming out. Okay, so this is the good candidate of the log function, another sort of log function. But here, yes, cancel it. Okay, say we cancel it, so 1 over 2, 1 over square root u. And this one, this is what I was talking to you, you just follow the formula straight away, okay? Not a big issue. Now over here, okay, that one, okay, is half u minus half du. This part is changing the format, so half times plus 1, 1 over power plus 1, power plus 1. Can you see? So that is a half, that is a half. So we're going to cancel them. So square root u. Okay, u to the half power is square root u. So this first integration will get changed to like this. It's so simple, like this. What's left, guys? What's left? Yes, do not leave the answer in terms of u. Say, take it back. Okay, put it back. Write it there. That will be the final answer. Okay, so we just covered the 8 questions so far. How do you think? Are you getting there? Okay, I'm pretty sure most of you having familiarized for this topic already. Okay, in terms of the log and everything. So we'll do question 9 to finalize the skill. Okay, how do you think over here? Okay, we are going to finally use the substitution method because it is so annoying. Okay, what you're going to do now, look at the idea. Try to differentiate this. That will be 2x plus 2. Okay, whenever you have the integration, okay, without having any sine and cos and trigonometric functions, in this sort of polynomial, it is always a good idea to try to differentiate and see what that is. And then we have 2x plus 2, but we have 2x plus 3. Yes, so close. So what my idea for this question is, just separate them. We love to have 2x plus 2 for some reason in the future. Okay. So differentiation of the x squared plus 2x plus 3 is 2x plus 2. So that's why we have 2x plus 2, and 1 is the other side. Okay. So that's the way how you start off. And the other one is, okay, for this one, we are going to use the substitution method. Okay. Knowing, okay, it's sort of headache. Say whatever you feel that is headache, substitute, replace it. Let u is the denominator, which is inside of the square root. Yes, you have to differentiate. Okay, so differentiate u in terms of x will be 2x plus 2, and multiply that. Okay. Okay, this is why I told you guys that 2x plus 2 is so informative. Okay, so 2x plus 2 times dx, 2x2 plus 2 times dx is this one. So that whole thing will get replaced by du. Okay, that's the whole part of the whole story. We'll jump on. So that's du. Okay, I write du over here, and this whole lot is u. Okay, this is u. So write u on there. And then second integration, we made the completing the square y. I'm going to use the formula 1 over square root x squared plus a squared and so on, like this one. Okay, so x squared plus something squared, which is, you can say 2 squared. So we can apply this formula over here. Does it make sense? Right? Oh, so this one is integrated like this. I don't want to show you so details. We have repeatedly showing the working. And this one is this one. So simply following the formula in the standard integral table. Your last step is put u back. That's the final answer. Okay. Okay. Let's recap all of the substitution. There are two things. The first thing is, what do you choose, or what do you determine to substitute? If anything you feel annoying, or anything you feel that's a headache, make it substituted by u. Okay, and second thing is, try to differentiate it and make it up there. Okay, or something else. Okay, that's how you do. Okay, so this is almost everything for the substitution of the polynomial integration. Okay guys, let's see you at the next lesson.